Huzzah! Hello. Hee Hello, everyone. Tonight we are going to do some electronics tinkering. I have so much stuff on the workbench right now. We've done some talking about what the plan is for the Protogen battery. Tonight we have no battery cells, but what we do have is the beginning of what's going to hold them. So the plan for tonight, we're going to assemble the trays. We're only going to focus on one battery right now. Once I have the process figured out for how it's going to be, then we'll just follow the same process to make the second one, because I want to have two batteries so I can swap. But for tonight, we're going to look at the trays. We're going to spend a lot of time assembling the trays. And then we're going to test the BMS, and we're going to test the voltage regulator. I also have the brain work for me. USB-C ports that we're going to use to attach to the battery permanently. That's going to tie into the voltage regulator. So the screens and miscellaneous 5-volt rails that are going to come out of the head are going to be attached directly to the voltage regulator via quick disconnect, which we don't have yet. And then the USB-C ports are going to tie also into that regulator. So everything's going to come out the regulator. But we're going to do a little bit of soldering tonight to play with the USB-C connections. And what that's going to look like for us is I have some developmental boards and some connectors that we'll be able to solder on so that we can play and verify that the plan in my head will be the one that we actually use. So sit back, relax, ask me silly questions. I'm going to pivot us to the bench, and I've charged my microphone, so hopefully we'll be okay. Yes, I see activity. I didn't even think to check. OBS has been resetting my stuff a lot recently, so I'm grateful to see my mic is moving. There's nothing worse than talking to yourself and then realizing that you're talking to yourself while you're muted. Ask me how I know. And I've done it too many times. So yes, that is the plan for this evening. So we're gonna chill, and then I'm just going to geek out as we proceed to wander through this madness. There's no battery cells tonight, but it's everything that's going to tie into it. So it's a fairly safe lab that we're going to work on tonight. So let's get into it. It's going to be a total of 12 batteries, and it'll be 6 and 6. So it'll be 6 parallel to 2 in series. So that's the plan. So without further ado, we're going to switch the bench. Yes, the bench. Bench. All right, good. Now, first things first. Okay, good. I see my mic moving. Good. All right, so with my current setup, I will be able to see you in chat, but I won't be able to hear you. My cord is not long enough. All right, let me see here. So I need to turn on. Hang on, I gotta go back a screen. I want that one. All right, good. my mic works. All right, so we got that action going on, and then let me get chat up. All right, fantastic. Okay, so I should be able to see the stuff and things that it's going to occur here. And I've got this, and I've got a mostly charged battery. All right, so let me drop the remote. Yes, I am a professional. I'm a professional of something. I'm not quite sure of what. There we go. Okay, now the camera's backed up the whole way. I'm not going to really be zooming the camera too much in and out, but I am going to tinker with the frame here a bit. All right, so you guys can see that, which means I can stick you guys over here so I can see chat. All right, fantastic. Okay, so for starters, I briefly touched on what the intent was going to be for the trays. So this is one of the battery trays. So I don't lie, I had to spend some time and figure out how on earth this is assembled because it didn't come with any instructions. So that's educational. So the way it essentially works is that for what would normally be the springy bits, there is just a screw and a spring that allows it to move. So through our normal process of building stuff, we're going to follow the usual rule that the negative will be on the springy bit and then the positive will be on the solid contact. That's how every battery tray I've ever witnessed is normally used, so we're going to plan on doing the same. So the theory first is that we're just going to put the trays together because they come very much not assembled. So that's what we're starting with. Once we have the trays together, we're then going to toss a little bit of voltage into our BMS and our voltage regulator. So we've got that action, and then also got breadboards, the pre-soldering boards, and our USB-C connections. So the USB-C has a JST connector on here, so I'm going to see if we can just solder on some test leads onto a test board and kind of figure out to see where that takes us. So at least goes the theory. So for starters, we're just going to open up all this stuff and then start tinkering. So this is the terminal for this one, and we're just gonna kind of figure this out as we go along. So I suppose we'll start with, thankfully the lids are the same on all these. So we've got that one, so that's 1, 2, 3. We'll make 4, 5, and 6. So we're going to do this in 2 assemblies of 6, and then we're going to see. I have not really played with them other than just looking and seeing that they do lock into each other. Beyond that, we're just going to kind of see how tonight rides out. I'm not really planning on doing anything too terribly permanent tonight, because the goal is to just kind of figure out the plan. But that doesn't mean we're not soldering. We're definitely going to do some trial and error here with all of this. We got 1, 2, 3, 4, 5, 6. Okay, so I got 6 of these, and before I start sliding them into each other, we're going to open up the kits. Then we're going to start dumping out the stuff. Suppose I will put these off to the side here. And then we'll start working our bits. So this, I kid you not, this is how they come. They come in a plastic bag. I got a tray. And I have I have a dream. Hey Sigma, welcome on in. Welcome to what's going to be probably a pretty long evening. I've got a bunch of battery trays and a bunch of hardware that's kind of off camera. And we're going to do the thing. All right, I try not to lose any of this stuff. So that was with that one. And then I'm gonna put these off to the side for right now. We are gonna come back to these because we need to make sure they work. I say that as I just dropped the regulator onto the ground. There you go. All right, good. Put you off to the side. Cause enough damage for one evening. Okay, so I suppose the theory here is that I know that I'm going to have to join them together. So before I start assembling, because like that's the action, right? They slide into each other. If we take a look, we could see here that the included joining piece does make it all the way to the side. So that's definitely going to help with the current arrangement. Now, before I snap it together, I am going to take a little bit of time here to work the hardware together. I'm not entirely sure just yet how this is going to shake out. Oh yeah, totally. Let me grab you a link. Never seen you before, so you are by all means welcome. For anybody else who is lurking, pretty much the way that we get access to the Discord is you come in, you hang out for a little while, and then you can request the link with a command. So let me do the thing. And all of that is just my anti-bot measure, or at least one of them. Because I've been in too many servers that have a lot of not so great stuff happening in them. So this is my sad attempt of trying to help run something that's a little less noisy. All right, hang on here. I want that one. And then I want that one. And then I want that one. I want that one? Yes. And I want that one. I want that one. And then through the power of the internet, we have that one. All right, cool. Inside of chat, that is the link. Hop on into the Discord. And that will get us off to the races here. All right, good. All right, now that we have that together, I have clicked enough buttons. And with that, I'm now back over here. All right, much excellence. All right, so to work on our assembly of all these trays, we've got... Howdy, gamer. Welcome on in. So we've got our two threaded bolts, but as you'll notice, this may or may not come across on the camera. Yeah, it does. So one doesn't have the threads going all the way up and the other one does. So from what I could understand from the way that this works, is the one that doesn't have the thread that goes all the way up is going to be the spongy one. That'll be the one that'll be able to move to get out of the way to, you know, accommodate for the size of the battery. So gamer, you say that in it's almost sketchy time because we don't have any batteries tonight, but we are going to go through the process of testing what I have so far. And not gonna lie, I was anticipating on actually doing a little bit of battery build. Well, I mean, sorry, all right, let me rephrase. I know we're doing a little battery building this evening, but the I anticipated. Okay, so I have to make sure I stack these the right way. So then the negative will be on this side, which means I need this one first. So I anticipated on doing some soldering of the actual battery components together, like to finish the trays off, but then I had rapidly discovered that the required gauge wire that's going to connect some parts of the battery together, I don't actually have on hand. So that's a me problem. I didn't double check myself, so that put me in the position where I'm gonna have to get my hands on some more stuff, but that's okay. You know what? I suppose I probably could put that the bottom brace on and then just kind of move stuff around here. This has been a bit of a figuring it out as we go along kind of thing. Now, something that I can tell you that's a little funky with this, actually no, I didn't even briefly show that on camera. I didn't do a ton of tinkering in my spare time because spare time has been hard to come by lately. But what I will be able to show you is the fact that we do have to actually adjust how far into the battery holder that that tray sits. And that's because the 18650 batteries, even though they're fairly uniform, this particular way of holding them is what would I refer to it as? There's like room for error in the way that these go together. Because since there's the springy bit that moves about, that puts us into a position where we need to be able to accommodate for the fact that stuff's gonna move. Now, since stuff is going to move, that means that we need to also assemble things in a meaningful order. Hey, actually, let me zoom the camera in a little bit better. I zoomed it out the whole way, but it's kind of hard to see what I'm doing. So this is gonna be a bit of a dance. I'm gonna try. All right, it might be a little too much. Back up a little bit here. All right, there we go. All right, let me see what that looks like. Because I want to be able to show you what I'm up to. And also have it so that we're somewhat visible. All right, so we're like right around here. Okay, all right, cool. Yes. All right, good. So what occurs here is that you need to have the threaded screw that's going to be up against the positive terminal of the battery. Has to be able to be far enough into the inside of the tray area. And if you back it all the way out so that it's all the way at the top, the spring doesn't have enough tension to be able to grab it. So it's actually loose in the tray. You can shake it. And it just kind of jitters around, which is less than ideal. So with our attempt at not making something that's too hilariously sketchy, that does actually need to be adjusted once the batteries are dropped in the tray. But to be fair, I don't have them yet. So that's something that we're going to have to adjust. I'm missing a screw. That's something we're going to have to adjust as we kind of go along once we get the batteries. But yeah, it's all right. I kind of knew this was going to be a little bit of a, you just kind of figure it out as you go kind of thing. And no surprise, that's kind of the direction we're heading in. So yeah, that's a thing. Oh, I'm doing this off camera. Yeah. Okay, there we go. By all means, say something in chat if I stop becoming visible. I'm working with really tiny pieces, so I have to see what on earth I'm doing, but I also want to make sure you guys can see what I'm up to. Okay, so then we got that, and then I want to be able to join it to the neighbor. Means I'm gonna need another one of those. I need one of those. Now, I don't necessarily anticipate requiring all of the screw terminals, but for the time being, I don't want to misplace them, so I'm just gonna briefly install them. I have no problem with just coming back and removing them later. It's 12 screws to remove. I'll live. My main point right now is just making sure that I don't lose any of the hardware, because there is an awful lot of little pieces of hardware that goes to getting this together. And I don't want to lose any of them. So, alright, so I got that. Got those joined, and then I'm going to join the bottom ones. And again, this is where kind of figuring myself out as we go along here. There's certainly going to be a part of the name of the game. But it's fine. I knew that this was going to be a little bit of a challenge just over the fact that when you don't join the pieces together directly with solder, that you're going to end up having a fair amount of dingly bits. So that means that we just have to be a little bit mindful then as we go along here, that we might need to do some adjustments as we kind of wander our way through, but that's okay. I'm here for it. It's a process, and it's one that I'm very much kind of figuring out as we go along. But thankfully, I don't think it's going to be that bad. I'm just kind of the mind that the this is gonna. I'm imagining this is just gonna turn into a game of patience, really, more than anything. Am I surprised? No, not really. Oh, howdy, Pine. Welcome on in. Pine, you get to watch me assemble what's essentially Legos for IT people. You have arrived at just the right time. That is essentially what this has turned into. I don't know if any of these would necessarily be qualified as illegal building methods for the folks in the Lego space, but I should ask Santa. He'd probably know. I refer to him, and if you know, you know. He's a good guy, Heral. Alright, so we got that. Alright, so we got that. Now, one of the things that I know for a fact I'm going to need to obtain that I just don't have yet is referred to as Kapton tape, and it is the type of tape that is used in electronics to insulate. Similar to electrical tape, but this stuff is seen more in consumer electronics to keep things less spicy, if you catch my drift. And in the realm of working on something that could potentially, cook me, I want to make sure I do it correctly. So the connection that's going to occur between both banks of cells here, because we're going to have 6 and 6, is going to have to occur with some pretty beefy connection, because when you connect multiple batteries together or multiple circuits together, you need to make sure that what you have is capable of handling the amperage load that you're going to be giving it. The last time that we looked pretty in-depth at this, we looked at how much power that was capable of being pulled through the project. I remember exact figures off the top of my head, but what it boiled down to is that the voltage, or excuse me, the amperage that we would need to pull to be safe. Howdy, Porsche. Welcome on in. The amperage that we would need to pull was more than what was considered safe for USB Type C. I'm going to refer to it as the dumb version, but it's the version that doesn't require any communication. So the thing is, with the newer battery technology, it's gone are the days where you connect a charger to a device and it just simply shoots electricity into it. To get one of those to get a more high draw in fancy electronics, there is a conversation that occurs between the device and the charger. And that conversation tells the charger what speed that it's capable of charging at. And I am not in a position where I know how to tell my electronics to ask for that. So I decided that what was going to work for us would be to use a voltage regulator such as this, build to provide the amperage with no conversation. So then that should realistically give us a safe mechanism. 2, 3, 4, two more. A safe application of electricity without worry of overdrawing. And the connection that has to happen between that regulator and the BMS, which is the other piece of circuitry I have over here we're going to play with, has to have a strong enough wired connection to handle that amperage. And that's referred to as the wire gauge, AWG. And the stuff I have on hand is 24 gauge? What do I have here? I have 22 AWG. Is this stuff? It's thin. It's definitely not thick enough to not cook the fruit. It's too thin by itself to be able to handle what I would need to ask of it. So in an effort to not cook myself, I just need to get some thicker wire so that we can connect the chains together. I spy a Porsche. Ah, hobby the fruit. The fruit be good. The fruit be good. The fruit's working on the project, and the fruit's happy about that because I have had these parts just sitting on my bench right now for a little while, and I've been desperate to want to sit down and work on this. And I spy a Cozy. Hello. Welcome on in. Cozy, I didn't get the opportunity to watch the end of your stream. Tell me things. The last I left off, you were interacting with the individuals to see how they were. Was there any other additional story after the fire had concluded in your story? Because I'm curious. I don't know if there's a VOD up, and frankly, I haven't had the opportunity to go look. Oh, that's exciting. Oh boy. So what you're telling me is that I should just go look at the VOD, which is valid. All right, let's see here. 1, 2, 3, 4. We got 6. I don't know why I keep counting. I have them already out. It's almost like a plan. Yes, I saw the fire conclusion, and Max was debriefing with everyone in the bar. Yes, that is where I left off. I was curious if any other story tidbits had managed to shake loose after I promptly passed out for the evening. Alright, so far I've got them all in the correct orientation. Bloop. So there is an orientation to the trays because they have to be able to lock into each other. So I do need to be a little mindful of which way they're facing. Now I think I'm going to be able to connect these enough that I could potentially pretend that the BMS is connected to batteries. I don't know if I have enough stuff for that. Maybe that won't be a thing. I can at least hook up the BMS and the regulator though to the power bench here that I have. I have some fancy wires that I'm going to use to hook up the stuff and things here so we can make sure that at least everything still works. Works enough, like I think it's going to. So at least goes the theory. We shall see. There is the quote-unquote final choice of the game, which I'm happy to talk about, or the VOD is posted. Well, if there's a bunch more stuff, then I suppose I will go watch the VOD. And for those of you who are not already following the lovely owl that's in chat here, by all means, drop Cozy a follow. I am very far away from my keyboard, Cozy, so I can't give you a shout out because I'm over here. I did it again, I'm counting. I don't need to be counting. I have everything I need right here. Cozy plays fun games. All story-driven stuff in Persona. Persona is an interesting franchise, and I love that between you and Hedgie that managed to like really kind of educate me on the whole Persona kind of, I don't know if franchise is quite the right word for it, but you know, it'd be what it is. Ooh, an unwinnable scenario. That's fun. So what you're telling me, it isn't all rainbows and sunshine. Fancy that. And for those of you who may be wondering how on earth I'm going to transport such a large battery on my person when I am moving around, don't you worry, I've thought about that. Because as we can already kind of tell, it's just getting kind of big. I'm not so worried about the weight, I'm just worried about making sure I'm not flammable. Or not any more flammable than I technically already am. Because let's face it, we are very much flammable. And the goal is to become less or equal to the same level of flammable we are right now. I was chuckling to myself because before I got live here, I am a really big fan of the science community, which is going to shock none of you. I was watching one content creator that was working on doing some really crazy chemistry. And I absolutely love his attitude because he's of the mind. He's like, I'm pretty sure that I've verified this enough that it won't instantly kill me. And I'm like, you know what? That's valid. Because at the end of the day, whatever you're working with, I would hope you're confident enough that you're going to be safe in your endeavors. Which I cannot stress safety enough when you're working with things that you may not necessarily be fully familiar with. You know, we won't learn if we don't toy around and tinker with things, but we also have to make sure that we do this in a safe fashion. Which is why, as you are all seeing me working on building something without any batteries yet, because we aren't there yet. Alright, so we got 1, 2, 3, 4, 5, 6 trays. And we'll put the rest of these little bits together. And then I want to see if there's I guess technically what I could do is use these little tidbits here to join the two banks together. I was debating how that part was going to work. Because it's going to have to join together and then the BMS is going to do the rest of the heavy lifting there. Which, well, technically speaking, I wonder if... Alright, so before I finish the end there, I'll open up another one here. I want to see something. I want to see that if we do put these on top of each other, like so. So there are holes in the bottom that would allow you to just kind of, push one into the other, but putting this into a scenario, I kind of think the bus bars are going to be long enough to go this way. Yes. Yes, they are. Okay. All right, we have our plan. I like that plan. All right, so I'm going to purposely not finish the end here. So I'm going to put these pieces for this one in here, and then we will come back to this. So we're going to get another one of these into the same position, and then we're going to work on joining them together. So for right now, I'm going to set this off to the side. Excellent. I'm going to grab a beverage. Cheers. Oh, that's still really hot. All right, hold up. So, hang on. I set it aside. I'm unsetting it aside because I want to look at something here for a second. Because I want to see, so we already know that we want to reverse. I want to make sure I assemble them correctly. Because what we need to do is we need to take the negative of this side and connect it to the positive of this side, but only on one side of the battery. Because if we do both, what do we call that? We call it a short. And we don't want one of those. Okay? The fruit likes his eyebrows attached to his face. And that's going to be part of the dance here. So, we already can tell that if I were to assemble another one, right, I would have did it that way. Now, then that would make that my negative, putting me that way. So, okay. So that means then that we'll do the same thing. We'll just make this bottom section the negative, and then we've got a plan. I like that. So then we can just reverse the whole thing, and it will still align with the neighboring teeth of the top portion of the pack. I promise that will make sense when you see it. Or at least I'm going to pretend it's going to make sense. Because it feels like it makes sense. until it doesn't. But for now, it does. I don't know what I'm doing. I don't know if I'm working on building a battery or having a philosophical nightmare. Maybe a little bit of both. I suppose, why can't it be both? One of these things is not like the other. I don't know how often they overlap with each other, but I'll tell you something right now. I'm entertained either way. Hope you are too. Oh, my word. Again, all this hardware that I'm carefully assembling right now is going to need to be adjusted once the rest of the parts arrive. Or once I get the batteries, because I'm going to have to tighten these down. And you'll see how it'll make sense once I drop a battery in here, what I'm talking about how things kind of go together, or how they don't go together. But I do like that I have the little screw terminal tidbits here. I mean, I suppose what I could do, help with assembly, is to just pick up some more of these blades and then use that to join all the neighboring cells together. Because something we have to be careful of is that there is enough surface area between the contact points to make a good electrical connection. Because if you have all this potential energy in the battery, but you have serious weak sauce that connects the sections together, well then you can experience electrical failure. And that usually ends up in having something catch on fire, smoking, insulation melting, or things just getting simply too hot. So if we just join all the neighboring cells above and below with another one of these bus bars, that might be enough. As all projects lead to. Well, I'm hoping that all projects don't lead to the toaster losing an eyebrow or two, but you know how it goes. Science. And the thought process of science. But that's also part of the reason why I know I'm a little frustrated with myself. I would love to order more parts, but half of this is just figuring out what I actually need. So it's hard to order what I don't know that I need. Because I'm hoping what'll come out of this evening is anything else that we potentially need for this to happen. Because I would like to know what I'm going to need to finish this portion of the project. As I put that on backwards. And this is why we double check our assembly. Because the pieces won't join together if I do that. Let's try that again. That is the bottom. Hee. I am missing things. Actually, no, wait, I'm not missing things. Oh, it's gonna be a long evening. You know, I'm kind of grateful I'm only working on the trays for just one of these. I don't know if I want to go through the insanity of assembling both of these in one sitting. I'm already working with enough tiny pieces. Alright, there we go, we got that. And now we add the bus bar. And the neighboring contact point. Alrighty, that one on there. Now we get to do the positive rail. And I have to admit, this is actually pretty clever on the manufacturer side, because this gives a very decently large contact point while also making the tray about as simple as it really can be. But don't get me wrong, these weren't exactly cheap. So that kind of plays into, you know, the project costs naturally. But the point being is that when you take on a project such as this, that you try to learn something along the way. I can tell you right now, I'm very much in that wheelhouse at the moment. because that means we might do something different for the next project. Like paying attention enough to join the pieces before putting the end caps down. There's this thing called learning. I don't know where I am. I'm still figuring myself out. It's because I started the first one in the set that I forgot I was going to join to the neighbor. All right, there we go. All right, we got that. And I get to do the same thing on this side. There we go. All right, so we got that on there. And we're going to add the next chain in command. I can admit though, I am really excited to work on making a lithium pack, because I currently have a device that works off of a fairly custom style pack. They're common, and I just recently purchased a replacement battery, and then, you know, promptly found out that the cells that were included in the replacement pack were kind of crap. So if I just build my own battery pack, then I don't have to really worry about the quality of the cells. If I end up buying something that's not so excellent, I'll know that while I'm working on putting it together. Because the cool thing is that if you're building it, you can test along the way to make sure that you're not getting caught off guard with what you're working with. Don't get me wrong, it doesn't necessarily mean I might not end up buying something that doesn't end up, you know, fit the bill. Like a battery that's rated for so many milliamps and then only gives off like a third of the energy, but obviously we don't know that until we try. All right, so we got that. One's oriented that way. All right, so we got that joined up, that joined up. I have to admit, at least it's easy enough to snap together. I'll tell you something right now, I had no idea what I was doing though when I first got them. I was very lucky to find the correct combination of words on YouTube to be like, help me figure out how on earth these go together. And the internet went, okay, here you go, this is what you're looking for. I'm like, thank you. Because like after I saw how the first one was put together in the example video, it then clicked, but like I did not start there. I looked at it and I went, oh, this isn't good. If it was supposed to make sense, I'm still looking for it. Alright, mighty fine. So we got that action, a couple more. And we get to test some stuff. Like continuity, for example. Hopefully we have enough continuity across all of the things. But that is one benefit of actually being able to assemble the container before adding the batteries. Because if I don't have a solid enough electrical connection between sections, I will find that out right now instead of later. Do, 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 do. That's- I have to admit, I'm happy that I don't do this all day long. I can only imagine if this is what one would be doing for a long period of time. I feel like this would be the exception of the carpal tunnel generator. And then oh, nope, never mind. Screw just traveled a lot farther than I thought it would. There we go. So when battery packs are normally spot welded together, they usually use this thing called nickel strip that gets connected between the battery cells. So it's kind of crazy how thin the stuff is that connects cells on most batteries that are sold today anyway. Because if you're looking at these little strips of metal and thinking, those seem kind of thin, you'd be correct. They are. And surprisingly, it's by design. Alright, so this one's going to also be the ending of this battery section, so I'm not going to fully assemble the back just yet here until we get a good look at the other tray, and then we'll figure out how we're going to try to join them together. Alright, so we have those pieces there, and then we have the first tray we started with, which we have right here. So, what we're going to try to do now is we're going to try to come up with a decent enough solution on joining them together. Now, we already know that we need the positive of one side to meet the negative of the other. So I'm going to flip this upside down so that we meet like this. Now, a couple things need to occur here to not lose our eyebrows. We want to join just one side together and not the other, which means obviously we're not going to have dangling bits in the final battery. Because if we join together the negative and positive of both sides of the battery pack, we aren't going to have a battery pack anymore. So in an effort to not do that, what we are going to do is we are going to assemble, for right now, what should be the remainder of just one side. Now again, I'm just putting these on here just so I don't misplace them for right now. My main goal is to come up with something that won't be a major issue. Grab that, and we'll grab another friend. Just toss it on here for right now. Because a part of the finished pack will end up having any extra material secured, so we don't have stuff just, you know, shaking in the breeze. I'm not worried about that right this minute. All I want to do is get together, which should hopefully be what we need to have happen here. So got that there. Did not finish assembling that side, so that came off, which is fine. But here, let me flip ourselves back over this way. This is the side that we don't want to have come in contact with anything else amongst itself. The bars should not touch. And what we'll do is we'll test it for continuity to make sure that as it is, you know, again, we still have to secure the shaky bits. We'll make sure that we're not shortening anything out that we don't want to. So we have that there. It's the extra one of those. Okay, so then this is the side we're going to have connected together. So I suppose, so things don't shake around too much, I've got 3 more bus bars to play with. I suppose we'll put one on the end here, and then we'll put the other one in the middle. Well, close to the middle, I suppose. So that can at least secure the edges together. Alright, so we have that there, and then I have 2 more. Let's do like here and here. Obviously, the other thing too, in addition to not having any of the dangly bits, would also be to tighten these joints with proper hardware. Like these will obviously be more than finger tight when it's going to be used for real, of course. But just for toying around purposes right now, while it's just a plastic and metal tray, we can kind of tinker here and make sure we got the right idea before we make any kind of serious commitments, if you catch my drift. Because once we start adding energy, you gotta be careful. Ain't a whole lot of going back once you do that. Okay, so as we had mentioned, oh, hi Snake, how you doing? You're joining in as we're playing with battery assembling bits. I'm doing too good today. Hopefully you could say you're doing the same. All right, let me see here. I've got probing bits, and we're gonna set ourselves to. We're going to set ourselves to continuity. Continuity means that if there's a connection of electricity, it'll beep. Which I don't know if the beep comes across on the microphone. Yeah, we shall see. So what I should have right now, from top to bottom here, I should have no continuity between the top and the bottom. Good. Because there's no. I am slightly off camera here. Let's position it this way so you can see what I'm doing. There should be no continuity between either side, and there isn't right now because there's no batteries installed. So first check. I don't have any shorts. Again, there's dangly bits, right? So if a dangly bit comes in cross with another dangly bit, that will pass electricity, which is funny. I'm trying to purposely make a short. There we go. There you go. So that we don't want. So that right there shows that on its basic level, I don't have any shorts. Now the next thing I want to check is to make sure that I do have continuity across every bar that's assembled. So if I just put one contact point here and then touch, should have continuity from all of these. Fantastic. And then if I check our negative, I should have nothing. Nothing, and nothing. Fantastic. We'll then check our connection between the bus bar sides. So I'll put one lead up here, and then I'll check the other side. Fantastic, I got continuity. I do the same thing for the negative rail. Fantastic, I have continuity. I check continuity at that point, and then should also have continuity across all of these. All sounding mighty fine. We'll check the negative rail. Fantastic. Okay, so that means that I have all of the sound bits and bobs where they need to be. Now that we have the battery tray enough together, just been doing boring adult stuff. Just sat down to have a bit of a break. Oh, that's fair. Hey, I mean, we all got to do the boring adult stuff, you know. And the reality is, you know, we do so much craziness in this world. If you need to take a break, you know, everybody should have a big red button in their life, you know, and you just kind of, you know, just press it, you know, and just kind of kind of break out of, you know, whatever funk you may find yourself in. And yes, that big red button's for a project, but I haven't gotten to it yet. that button's seen some action on this channel before. But yeah, fun times. Okay, so now we have a bunch of battery trays, and they're electrically connected so that the positive of the top of the first battery goes into the negative of the one below it. So then that leaves us with a negative and a positive rail that makes up our whole battery. Now, something very important to note that it's kind of hinted at when you're putting together something like this is that I have a negative connection here with the spring and a positive connection at the top of the post, right? Now, if I try to do and take a measurement of voltage, or I try to draw, if I try to draw amperage out of this battery pack, and I were to put a wire here on this positive, and then a wire here on this negative, I'll get power here, but it's not going to be a part of the whole pack. So if I want the power from the whole pack, I'm going to use one of the positives from this side and the negative from the opposite side, so that we have negative and positive to make up the entirety of the pack. Now, what's going to make this pack safe is the BMS, the battery management system. So that is this little guy right here. So a couple things are going to happen. There's power supply in and out, positive and negative. There's the battery contacts, positive and negative. And then there's a BM pad that's over here. So what this does to make sure that the pack charges and doesn't overcharge a bank of cells, since there is a series connection between the front and back sides, is this BMS lead will be connected on this side of the battery pack. It doesn't matter if it's on this side or if it's on this side. They're electrically connected to each other. That lead just has to touch this side of the pack, because what it'll do is it'll allow the little computer to determine how much voltage is in this side and how much voltage is in this side. And then if one side has reached its full charging capacity, it can draw power through this pad to prevent overcharging of the pack, so that all the cells can get charged up. What we want to check on this though is, will the cutoff voltage work on this? So every pack is supposed to stop draining at one point or another. So what we're going to do now is we're going to do a quick little bit of battery math. Get my test leads out. Because the theory here is that if I was hooking up the battery to this, which I'm not because I don't have them yet, we would have a expected voltage, and then when we get below said expected voltage, then we stop working. Every battery pack does this to be safe, as it's called low voltage cutoff. And when we reach the low voltage cutoff, we stop sending energy out of the battery pack. This is to prevent overdrawing the battery, which would be an unsafe condition. You never want to draw a lithium battery all the way to zero, because that is how you damage the battery. And if it's in a bad enough case, you will lose the battery. So what I'm doing right now, slightly off camera, is I'm attaching our test leads to the variable power supply that we've used in this this environment before. And it's fighting me. I'm working on getting these on here. Probably be smart if I'm not trying to do both of them at the same time, but it's probably fine. Just have to get them under the pinch point so I can tighten down the screw. Because what we're going to do is we're going to simulate having a battery connected to the pack. We can make sure that our BMS works correctly. Okay, so now what we've got has a bunch of alligator clips that are hooked up to the power supply. So we're going to use our alligator clips. I'm going to be smart and plug in the cord for the power supply so I can turn it on. Because if everything goes according to some shape of a plan, we're going to make sure this works. Alright, so right now, we've got our power in and out on this side, and then this is designated to be... I need to do some quick math, and I'm willing to rotate and pull up my calculator, because if I do it wrong, I can damage this. I don't really want to do that. So 3.7 volts times 2 works out to a total voltage of 7.4 volts. So what we're going to do is we're going to set the variable power supply to be 7.4 volts. Now a full charge would probably be a little more than that. There's going to be a little bit of variability in that, which is fine. Not big of a deal. I'm going to turn on the variable power supply, and then I'm going to set myself to 7.4 volts. That's 6. Gotta keep going. 7.2, 7.4 on the dot. All right, fantastic. Okay, so what we're going to do is we're going to mimic being the battery. So what that's going to mean then is I'm going to attach our alligator clips to the battery terminal side, and then I'm going to use the multimeter we have here to read the voltage coming off of the power side. Now this is going to be a little tricky because we need to get a couple things together here to make this happen. Actually, you know what? Let me grab the fifth hand. I think this would be a good time to have a whole bunch of alligator clips involved. But a moment while I get us oriented here in a reasonable fashion. We're going to be in there like that. And then the next thing to occur is I'm going to pretend to be the battery, and I'm going to connect the negative and the positive. Now I would anticipate no amp draw, but I also need to pretend to be the positive lead for would need to be half the voltage. I don't know if I'm technically able of tricking it into thinking that. Because what we would be getting is the full effective voltage. Well, here, let me check it. Let me check it before I tinker here. So let me set our voltmeter back to 9 volts of DC because we're never going to go that high. And then I'm going to put my test leads on here and see if there's anything coming out of the BMS right now. We're seeing exactly 7.6 volts. Fancy that. Now, we're not charging right now, so that seems to be reasonable. Let me see if I can wedge these in a way that I can turn this without having to touch it. There we go. So we got that one set. And now let me get the ground set. Because I'm not really too terribly worried about the power going out, but I want to make sure that it cuts off at the right voltage. All right, Fantastic. This looks like something out of a science fiction experiment. I would try to rotate. I could probably carefully tilt this. Yeah, that's the action we have right now. It's looking like something, all right. Okay. The theory here now, I am reading 7.5 volts. It jumped up a half a volt. That's fun. Or a tenth of a volt. I'm going to start turning this voltage down, and I believe the hard cutoff should be somewhere around 6 volts on the variable power supply that you guys can't see that's off camera. If this works the way it's supposed to, then once I turn that knob, once we hit around 6, this should just immediately jump to 0, because that means the protection circuit would have cut in on this little board. So, all hoping it goes well. We're going to start going the other way. I'm at 7 volts. And I'm putting out 7.1. Interesting. So it has a little bit of an uptick on it. So let's go down to like 6, almost maybe 6.5. 6.4, 6.5. All right, so it seems like the power supply side puts out about like almost an extra tenth of a volt. That's interesting. I didn't necessarily anticipate that. We're going to keep going. Like I said, at some point, it should cut off. It should stop putting out power. We're going to keep going. Ooh, look at that. So, all right, so it works. It works. So I'm at exactly 6 volts right now on the variable power supply, and this is reading 6.09. I'm going to move this slightly a little bit more down, which should just immediately cut the circuit off. So I'm going to use the fine controls on this power supply and try to just take off an extra tenth of a volt. So that is 5.9 volts. We're going to keep going. I'm heading towards 5.8. Get there here sooner or later. Come on. There we go, right there. So that's 5.8 volts. We should definitely cut off here sooner or later. Well, let's keep on rolling down. Might run out of fine control. I might have to switch knobs. I'm still at 5.8. There's 5.7. At some point, this is supposed to cut off. It did cut off briefly, though. I'm not sure why it popped back on. I would think it would have completely just gave out by now. Then let's just keep on rolling. Should cut out here eventually. Alright, so I bottomed out my fine control, so I have to zoom this back up for a second. Get more control back. And then I will use the coarse control. I went a little too fast. That's okay. Alright, so I'm back at 6 volts. I'm going to start bringing it back down now. It does work. I'm just trying to find that effective cutoff voltage. Controls are really finicky on this power supply. So there's 5.6 volts and it's off. So let me try to add that extra tenth of a volt back and see if it kicks back in here. There's 5.7. 5.8. No, 5.8 don't seem to do it. So it seems the effective cutoff is at around 6 volts. That's about what I thought. Try to just nudge it back to 6. Yeah, so it seems that after we get beyond 6 is when we just kind of die. So 5.6, immediately dies. 5.6, 5.8. Can I get 5.9? Do I have enough travel? I don't have enough travel. And the fine knob. Of course I don't. I can't express to you guys how unbelievably touchy these controls are on this power supply. Alright, come on, give me 5.9. There's 5.9. Alright, and now we're going to keep on traveling back to 6, and I'm going to anticipate. Yeah, right there. Okay, so the cutoff is at exactly 6 volts DC. As soon as it hits that, it shuts off. That's perfect. That is what a battery management system is supposed to do. It's supposed to cut off the effective voltage when the pack gets low enough. Now, when you're not working with a battery that has, when you're working with batteries that aren't in a pack, that don't include this type of standalone circuitry, what we end up having then is a protection circuit that's built into the top of the battery head. You'll notice that on a lot of lithium cells that you could purchase, there's a bump on the top. That's the protection circuit, which is very interesting. Now, something else I would like to know is if our regulator works according to plan. So we're going to work that into this next. Now, the regulator, which is of this component right here, is going to take the full voltage where these probes are right now and then drop it from whatever voltage it is, or I guess increase it if it's too low, right? Because no, technically our cutoff voltage is 6 and we want 5, right? So this should never have to boost the voltage. It should only ever have to buck it down, which is fine. That's okay. So let's make sure this component works as well. So we know our effective voltage cannot go. In theory, when it's a full charge, it could be closer to 8 volts, but you know, that's the fun of it. Here, I actually don't want to turn that off. I'm just gonna leave that there. I am going to, for a moment, turn off the power supply, which we'll see here. All right, good. All the power is out of this. All of the power is out of this circuit. Now I can bring the probes back, and then I can take our battery management system out of here. Excellent. And the other thing I was curious about, this did not get warm in the slightest. I was genuinely curious if this was going to get warm at all, but the top of it's completely cool. Okay, so then the next order of business is going to be our next toy, which is VIN in and ground on this side. So VIN in should be the power supply side. So that means we're going to take our positive there, negative. I have to do this with more than one hand. We're going to have the ground there, and the positive there, like so. Okay. The next part, I'm going to be finding a place to clamp this goofy thing. There we go. I'll clamp it in the middle. This has got a rubber boot on it, so it won't short anything out. Let me get that in the frame of the camera here. There's a rubber boot over that center, so that we should be okay to not short anything out. Okay, so now the next thing we're going to do is we're going to bring in our leads here. Bring them back into view. I'm going to have to, there we go. Just move the entire assembly forward so you can see what I'm up to here. What are you doing this evening? Watching a toaster build a battery. Hey, if we don't test to make sure all the things work, then we're not doing ourselves any favors. Okay.
now I'm gonna attempt. Again, the variable power supply is off right now, so we're not risking anything by manoodling these leads around. There, we got one there. And making this difficult on myself. Just need to push this back a little bit so I can lean. There we go. There we are. Okay, so now I'll push that back into frame. So, oh, Cozy reached a 5-streak stream. Very nice, very nice. Thank you very much. I did not forget. I don't BS. I didn't forget. I am working on a watch streak command. I have the sticky note over here on my desk, and I think I figured out what I want it to be. I just have to work out what audio I want to put to the command call. Okay, so what we should witness here on the meter, I'm going to move this slightly out of frame so that this is a little easier to read. What we should expect to see over here is nothing but 5 volts. We don't have the cutoff circuit, but what we should see is that we're going to purposely send the variable power supply all the way down to 6 volts, and we should still continue to see 5 on this the entire time I'm screwing the little adjuster off camera here. And the other thing too is that this particular device is designed to handle a larger voltage than what it puts out, so I'm comfortable with leaving the leads connected when I turn it on. If it can't handle the sudden voltage of a power supply turning on, then this is not designed correctly. So without further ado, I click the switch. I'm drawing 0.01 amp, and we are putting out a nice 5.18 volts DC. Now, the next part of this little venture, I just noticed is that there's a little red light on the board, which is going to be really hard to see, but right below the negative lead here, there's a little red light that kicked on. I'm going to start increasing the voltage to get us all the way up towards probably about 7.5 volts, which is in theory the highest that we should see on our battery pack. So I'm going to be careful here. I believe, actually, where's my phone? I say, where's my phone? I'm looking at my phone. That's chat. All right, hang on, guys. I have to tab out of chat. I'm not going nowhere. I have to tab out of chat here to look at the maximum voltage this thing's capable of handling, so I don't actually fry it on camera. Oh, Hobbit's joined us. Well, hello, Hobbit. You've got your coffee. That's very exciting. I want to say this thing's capable of 20 volts, but I want to double check. There's never been a point where I would be willing to completely fry a piece of equipment that I very much need on purpose without looking. Alrighty, friends, this thing is a step-down buck converter that's capable of doing how many volts? Tell me your secrets. If I was prepared, I would have written it down somewhere, but I didn't. Maximum input is 25 volts DC, so that could actually go up pretty high. I wish I had some coffee. Release the magic blue smoke. No, no, it's been struggle enough to be able to make sure I'm not only having the right components, but ones that work. Okay, I'm gonna slowly increase the voltage. I have no intention on going above 10 volts. I can tell you that right now. I'm not willing to do bad things to this. So, all right, we're starting to climb. We're at 6, we're at 7. We're headed to 8. That's 8 volts DC. We're gonna climb to 9. That's 9 volts DC. We're still reading 5. And then I'm gonna get us all the way to 10. All right, that's 10 volts DC. As we can see, the entire time I was increasing it, this number never changed on the multimeter because that's the output of the voltage regulator. Now, I'm gonna move our test leads over to the power supply side so you guys can see and witness I'm not lying. Put these on there. And what do we read? 10 volts. 10 volts is how much that's going into it. And then what? Again, what's coming out of it? I'll put one there and put one there. And we read 5. So that goes to show that the voltage regulator is not only doing its job, but I've also purchased the correct kind. When I was looking at these online, they come in a variety of different voltages for output. Heatsink's not getting warm. That's good. There's a heatsink on the top, and I'm like, yeah, you know how that is. I'll make sure I'm not, doing bad things. I'm going to turn this back down to a comfortable 7 volts. Actually, let's pretend we have a full pack. So that would be what, 7.4 volts. I'm going to scoot all the way back down. 7.4 volts. Yes, we know in theory it could be higher, but double check myself. There's 7.5. I'm at 7.4, but that's okay. It's not going to be perfect. And we're at a smooth 5 volts, which is beautiful. Exactly. Nothing is blowing up yet, including myself, which is definitely a part of the plan. All right, good. The next thing on our agenda here for this evening, let me take a look at the time. So we have been live for, I can't read those numbers, they're too small. An hour and a half. Okay. What we're going to end with this evening is we're going to attempt to test the USB-C connection wires that we purchased to make sure that we get 5 volts. Now, one of the test leads, I'm going to turn off the variable power supply because this next part, we're going to need it, just not yet. All right, good. The little light went out. Good. So that's nice to see that this actually does tell you things. I'm thrilled that didn't even get warm. Good. Because I had promised this was going to be a battery pack that I'm carrying around, and the last thing I want is for it to get too terribly toasty. All right, so I'm going to move this out of the way for right now. All right. And for those of you who are just joining us, this is the beginning of our battery pack. We've got these clear little covers that go over the top. The next part, though, is going to be the USB-C connectors. These have on them a JST connector. What we've got there is we've got our USB-C, and then we've got a little adapter like this. Now, I probably should plug in the soldering iron, because we're going to need that this evening. I'm not entirely sure of exactly how this is going to pan out, but we're going to try. So what we're going to do is we're going to take, because we do need 2 of these, because we have 2 things we need to plug in, right? Because we have 2 microcontrollers. So what that's going to turn into is I'm going to open up my magical little kit of stuff and things, and we're going to find the correct connector head, because this should be a simple 2-prong JST connector. Now, I do know that calling it a JST connector is a little bit like calling electrical wire Romex. Romex is a brand of electrical wire that runs through the walls of American homes. But unfortunately, for a lot of us, it kind of, all feels similar when it comes to branding versus what it is. You know what I mean, but that's not what it is. It's part of the fun. All right, so we got that. And then I'm gonna put this over here. And then these I'm gonna just set aside for right now. We're gonna come back to them because we're gonna work on our friend. Now, debating how I want to go about doing this. Alright, so let's move this out of the way. And we'll put that over there. And then I'm going to plug in the soldering iron, which is currently just sitting casually off camera. Alright, so I have the soldering iron plugged in, and I'm going to turn on its main power. And then I'm going to turn on the iron, which is this side. Alright, so that's preheating to 700 degrees Fahrenheit. And I need to take a moment and go wet the sponge. And the theory of what we're going to do is we're going to work out a little connection board for us so that we can test our USB-C wires. Okay. And this is one aspect of having a mic pack that's wireless. I could bring you with me. Alright, so now we have one very, wet sponge. And now that we've got the wet sponge, we're going to need a couple other things here. We're going to need some solder. I do have the flux. I don't think we're going to need it though. Because what we have is we have lead-free solder. So I do have flux paste, but I don't think we're going to need it. We're going to work with that. And then we're going to see where we end up. All right. So I'm going to pull these out of the way, that out of the way, and then all we're going to do, all I really want is to just bring this back over, not so much to clip anything, but to just have a nice solid metal surface. Because there's already one burn in my mat, and I don't really want an additional one. Alright, so this, if you've never seen one of these before, it is a developmental board that allows you to, similarly to a breadboard where you just plug components in, this allows you to solder them to something to make them a little bit more permanent. But as you can see, none of the traces were actually joined together. So part of working out our test board here is going to be also joining together multiple links to make the electrical connections. My stream crashed on my phone. No, it did not. Goofy thing. No, it didn't. It's lying to me. Alright, so we got that, and then actually that should be more than enough out of the way. Okay, so what we know right now is that we do have a positive and negative to our endeavors here. And when this gets plugged in, that's going to mean that the right-hand side of the connector is going to be the ground, and the left-hand side is the positive when looking at this from the front. So I'm going to grab myself a Sharpie. Hope I have a Sharpie. I have a marker, right? I have so much crap in this office. There's bound to be a marker around here somewhere. Here, I found one. To make it so that I don't lose myself in the process, I'm going to just add a little mark on this side to remind me that is going to be the negative side. That's going to be important later. Alright, fantastic. Because we're going to have to put together the little bit of action here on the other side. Alright, so I want to leave a little bit of breathing room here so we're not on top of anything. So we're just going to do... Let me think about this for a minute, because we are going to need to technically join a set of these together. right? And if we do that from the bottom, oh, we could just run them in parallel. That's actually not a bad idea. So if I do that, 14 doesn't really line up with any of these contact points, but 13 and 12 sure does. So what I'm looking at here is these contact pads on the top to the little holes on the bottom. And to make this really unbelievably easy, actually here, before I do that, before I commit, I want to check something. Because I don't know, we're going to do a quick continuity check here. We're going to make sure that if there's electrical connection or is not between those outer pads, because if they are electrically connected, that is going to slightly change my plan of action here. So, all right, so there's that. And if I pick this up and I touch outer side and this side, I don't get anything. So if I touch top side of this pad, and double check myself here, the underside, there's no buzz. So there's no buzz if I touch. This is very hard to do and show at the same time. Hey, welcome in, Aset. Aset, you're here for the experience. I don't know why I'm making this so hard on myself. I have a thing that holds a thing. All right, so we're gonna do one there and one on the opposing side. And we currently hear nothing. Since we do need to use some electrical wires here to make sure that things go somewhat according to plan, because we're going to need to attach technology. Yeah, exactly. Welcome on in, buddy. It's good to see you. All right. I like this plan. I'm also going to put myself not quite on the edge, like so. All right. And this will make some form of sense once I show you what on earth I'm doing here. Hey, welcome on in, Thunder. Fancy NASA badge. I love it. Love to see it. All right, so I need to make sure that I don't accidentally short out the sides here. No explosions. Oh, there's bound to be plenty of those. That's funny. I was actually talking to a couple of coworkers today, and they're like, "What are you doing this evening?" I'm like, "I'm building a battery." They're like, "What?" See, I love the reaction, because if you immediately look horrified, you know the danger that is associated with working on batteries. Now, we all know that there's no actual batteries involved with this evening. This is all prototyping. But I'll never get over the wide-eyed expression like, oh no. I do realize that at this zoom level it's going to be impossible for you guys to see, but I will show you once I get the solder on here what on earth I'm up to. Because the goal right now is to heat up the joint without melting the connector. ESA also helped on that mission. Educate me, Thunder. Who is ESA? I'm imagining they're another spacey bit individual, but I actually don't know the name. European Space Agency. See, that's a problem. The dumb Americans should at least know of the existence of other space people. What do I know? I'm just a guy who's just doing electrical engineering in my spare time. That doesn't mean I'm smart. That means I can look stuff up. I'm good at Google. This is not getting hot enough. What's going on here? We're at 720. I am at melting temperature. What am I doing here? Switch this up here so I can put my hand on this side. I have to be really careful that I don't bump this, because this is like all flavors of ungodfully hot. a little bit closer there with the edge of the. Bent the wrong way. So you're gonna love the answer to that question. The answer is no, but there's also no batteries currently involved in this particular interaction, so we're safe. All right, that's the first contact. Fantastic. Now I just got to get the other one on here. Nah, it's okay. I plan on having the safety measures situated when it comes to that side. No potential energy this evening, just the variable power supply. Nothing out of ordinary. Alright, so I accidentally just joined a couple here. Let me see what we did here. Speaking of Google, felt my bones crumble to dust tonight watching a movie trailer, and rather than having a website, it said America Online keyword. What? Watching a movie trailer, and rather than having a website, it said America Online keyword. Oh, well, that's exciting. It's okay. We all get to feel old eventually. Geez, I haven't thought about that type of communication in what feels like forever. All right, crew, we're gonna have a little bit of space here between these connectors. So far what we've got is we've got an electrical connection right there at the top, and then I just have the pins down here for the next set, and then we get to join these rows together to get an electrical connection, and then we'll add some wires, and then we can test our jacks. Okay. Okay. All right, so good news. We have our two jacks installed, and right now they are not electrically connected. As we can see there that the pads are not touching yet. So the next thing is going to be involved is bridging these together, and then we're going to push a set of wires through the board so that we can actually hook this up to some power. We'll hook up our USB-C, and then we have our testers. We'll hook those up and make sure that those work. Next weekend, we got an invite to participate in an exercise in another municipality by our fire department there. I don't want to go. Oh, come on. It's not like they're going to set stuff on fire. Maybe they will. I don't know what the protocol is to hanging out with other firemen. I'd ask the question of what it would mean to be like, y'all just like light stuff on fire. I don't know if I want the answer to that question. I mean, in theory, you have to. I guess you have to light stuff on fire to learn how to put the stuff out, right? So, like, I guess in theory, you technically would be. I'm gonna attempt to put this in the hand to try to do this so that it stops wiggling around. We're gonna try anyway, because the goal here is to join. I just bent that. That's not good. I meant to bend the arm. While everyone just sits and does nothing. Spring water on a roof. Alright, fair. Alright, good. It's secured. And I can kind of get it in frame. I knew Europe had at least one space agency, but I didn't know it was called the European Space Agency. Well, it is. That makes me feel a little bit better than that I didn't know. I mean, I'm also the toaster that lives under a rock, so if you're looking for current events, you've come to the wrong location. Can confirm, there's a lot of places to go. This is definitely not one of them. Dude, it started to melt as I bent it. Oh, damn. I didn't just join these together. My goal is to get this hot enough that I could join the pads together. They launched rockets from French, I don't know how to say that, in South America. Yes, France still has land in South America. I don't know, man. I don't do this whole global thing. The global thing just kind of tends to find me. And we just kind of go from there. I like how soft the solder is, but at the same time, I hate how soft the solder is because it keeps moving around. Need to be able to heat it up here and get a ball of solder to piece to join together. All right, now we're in business. I got a big blob. You know, this blob is going to get connected to this blob. Almost there. I'm sure that there is a more elegant way to do this, but that's what we're doing. Well, for the time being, I don't know what we're going to do as the actual production solution for the actual connection between the two pieces. I'm probably just going to end up chopping the ends off, but for the time being, I want to play and just kind of see what we can do. But I've had these boards for a long period of time, and this gives me an excuse to play with them. The French Empire is larger than the British Empire. I really love how these blobs are trying to stay separate. It could be my angle of attack here. I do have this kind of rolling uphill. So what if we roll downhill? What are you going to say about that? I probably have a really nasty electrical connection between both sides now. I've made a really nasty mess here. Actually, let me get a good look at that. I don't know how there's any way that those are not shorted out at this point. All right. Well, let's move that out of the way and see if I can, salvage this mess I've just caused myself. Well, I'm pretty sure these are shorted together, which isn't going to be any good. Yep, that is literally the opposite of what I was trying to accomplish. That's fun. Good news, bad news. I kind of fixed it, but now the jack fell out of the board. Yes, Cozy, that does make me feel a little bit better. Well, I've got a blob of solder that came out of that side, and I'm pretty sure these are... Let's actually just check and see if they're electrically shorted together at this point. My God, somehow they are not shorted together. I don't know how. That is fascinating. All right, well, now what's my plan of attack? I suppose. I mean, in theory, I could just heat it back up and probably shove it back to the board, but that might cause more trouble than it's worth. I mean, to be fair, I do actually have the ability to put the ends back on if I cut them off and decide I changed my mind. And also, these pads can be resoldered. I'm actually not looking at them. Small executive decision I just thought about that what I could do that I didn't think about before, as I almost dropped my phone. There we go. I'm gonna do a thing. It may or may not be a smart idea, but we're gonna try it anyway. Because my goal was to get access to those. I just plug it in. I probably can add some connection to that, so alright. Alright. Here's what's gonna happen. I'm gonna pick up my phone that fell over again, because There we go. All right, guess what's gonna happen? I'm gonna grab this, and we're gonna grab that, and I'm gonna unplug that, and that's gonna give me that. And then I'm going to grab the leads from this, and we're going to carefully connect it to the alligator clips that I have on the workbench. These are stupid close to each other, so this may or may not be a good idea. No, there's no way I'm going to be able to do that without shorting out the connection pins. Well. Okay, no. I'm being a little dumb. I'm being a little dumb, slightly dumb. I will explain why in a moment when I get this back in front of the camera. Because if I do it this way, all right, you're gonna see this, and you're gonna understand why I think I'm silly. Because just to test to make sure that these work, there's our connector, and there's me bypassing the connector. So the theory here is that I'm going to turn this back on. That was set to 7 volts. That's why we don't have it connected right now. And I'm going to zero this back in at 5.1 volts, because that's what we were seeing on the other end of the buck converter. We're going to go all the way down. 5.1. I am now at 5.1 on the variable power supply. So now I'm going to attach ground to ground. And then I'm going to grab our USB meter, and we're going to check and see what we get out of it. Because if I have everything correct here, should be able to comfortably plug this in. Oh, sending myself to the moon. And just like that, I've got 5.2 volts over here. I wanted to do 5.1. Back down a little bit. Alright, so I am set to 5.1 volts on the variable power supply. The plug-in connector is reading 5.2. At idle, it's drawing 200 tenths of an amp. Thunder, you're always at work. Come on now. Now the next thing I want to see here. D plus, D minus, C1, C2. Interesting. I'll cycle through the different screens here. Work pays. I don't get paid for anything I do. Fair. Alright, so if I bring this up into action here, we can see that the jack works. Is good. And I suppose this would be a really quick way to check the other ones too, to make sure they're okay, as they are. Because I'm going to need 2 of them for our project. And just making sure that what we have right now is going to work. Ideal. I have to admit, I'm not a big fan of how these were particularly put on here. Sync mode is on. I don't know what that means. It works. So that's part of that right there, which is good. That means that those work. I'm kind of under the impression that I'm just going to end up probably chopping that off, and it's going to get just soldered on to the pad of the regulator. But the thing is that what I wanted to point out is the thickness of our cables here that we're playing with. Because currently what I have at my disposal is the this really thin cable. Is really, really small. And the connection that needs to be made at the battery tray level has to be fairly beefy. And if we were to compare that to the wires that connect to the screens, you would then know that that's a little bit to be desired. So obviously we need thicker wire to be able to connect the chunks of the pack together. I like the idea though of joining these together using these little crimp leads that are on here. Now granted, I have the couple bus bars and that's fine, but if I use that, that would take care of that. And then as far as this side goes, I'm probably just going to take off the extra ones and then put some kind of substance to keep this from moving about. And then there's going to have to be some kind of figuring out of how these two are going to get secured to this battery pack in a way that keeps everything secure. So we have the beginning of what this is going to end up looking like. I have to admit, I'm not the biggest fan that they didn't push the wire through the little board here that this is on. But again, these are not exactly the highest quality. So we'll see. I really want to get this secured so that it will be comfortable to be able to push the cable in and out of here. Because my big concern is that USB-C connectors, as far as they are fairly delicate, and this did not come with any mounting holes to secure this to anything. So that's going to be problematic, but we'll figure it out. I'm not too terribly worried, but it might involve some tinkering to kind of figuring that out. As far as where we are for this evening, though, that's about all we're going to do for tonight with the toying around here. I've got way too many things on my workbench, and I've got wires absolutely everywhere. I definitely think that I'm probably going to tinker with this little disaster off camera, though, and see if I can come up with something. Because it wouldn't be the worst idea to affix some of the parts to one of these. But I made a heck of a mess out of this one, so that's okay. I've got more of them. We'll do a little tinkering and see what we can come up with. Thank you, Cozy. I appreciate that. It's very much a we're figuring it out as we go along, and that's part of the reason of what I like with these kind of projects. That was the sound of my water bottle falling over, but the cap was on tight, so that's good. I already knocked over a cup of coffee today, so if I can not make more mess for myself to clean up, then that would be preferable. Okay, good. All right, hang on. Let me get back over here. Huzzah! Ah! All right, fantastic. Stuck on here. I'm gonna fix my shoulders. Boop. Hee hee. Much excellence. The prude helps clueless, non-techie brain beans. Hey, you know, Hedgie, we do have to talk 3D printing. I'm hoping you're feeling better, cause my goodness, my guy, you sound like you had gargled rocks. That's a rough place to be. So hopefully you're feeling better. Cause it's no fun being sick. I am excited for this though. It looks like, at least with what we have, we should be
have, other than just like the wire and joining the separate sections together, I think we have everything we need for the major components that are going to make this pack work. Have to pick up a little odds and ends for making the pack quick disconnectable. Better yes, just stuffing a little cough. All right, good. You're getting over it, which is good. So I'll have some other little bits and bobs I'll have to pick up here for them to make this happen. But then, yeah, we'll do a little more tinkering and see where we land from there. So with that, let me take a look and see who's floating around here.